Hi, today we will be bringing you a video tutorial from Daniel, Liam and Hannah on the basics of 3D plotting. This tutorial will provide you with the tools to build your own 3D scatter plots in R using various packages. There are multiple packages with varying degrees of difficulty and usefulness. For this tutorial, we will assume that you have a basic understanding of R already. This includes basic coding commands, a grasp on linear regression and how to use it with the base graphics package in RStudio. If you do not have this, we would recommend the R-Swirl tutorials to achieve this starting knowledge. Find the link in the top left of the video as well as some other resources in the video description. 3D plots are useful for plotting datasets with two or more predictor variables. The interactive 3D plots are particularly useful for pattern recognition that may be otherwise obscured on a 2D format. Often with datasets that have both positive and negative effects from different continuous variables, as well as factors, information and relationships can be lost in the 2D format. There are some pretty amazing things you can do with plots. Here's a star map made in RGL. Okay, now to get started on making 3D plots. For this we'll be using one of CAR package's built-in datasets, so you can do this on your own as well. The dataset is called soils and has numerous factors and chemical concentration values to predict the conductivity of soil. Interesting, right? R has a built-in 3D plotting function called persp. However, this can only create wireframes and is not useful for predicting the outcome of statistical analysis. Here are some examples of the persp function. I'm sure you can see how this is not useful for our purpose. These are the packages you'll need to preload into R if you want to follow along. We will explain what each of these packages do in more detail as we progress. First, we are going to use the Lattice package. This package is mostly used for plotting trellis graphs. However, it can be used to plot very quick 3D plots. You can build a basic 3D plot using the cloud function. Cloud works much in the same way as the plot command within R's base graphics package. As you can see, this makes a very quick 3D plot. It's not as polished as it could be. However, if you just want a quick visualization, then the Lattice package is perfect. If you want to improve the plot, the first step would be to remove the outer box. You can then start by adding extra arguments to the function. Most are the same as the base graphics package. par.settings removes the outer box using a previous line of code. Groups allows the ability to represent a factor, the standard being different colours, but this can be changed. Aspect allows you to create a ratio for the size of your axes. Panel aspect changes the level of zoom, and screen changes the angle of the plot. Here's an example of a change of panel aspect and angle. This one is an example of the most important aspects of cloud. There are other settings we haven't used, such as the ability for wireframe graphs. These are listed in the help files for the package if you wish to investigate further.
Our next package for 3D plotting is called scatterplot 3D. For this package and further ones we will show you, the data frame must be converted into a matrix. Split the dataset into your x, y and z variables from the matrix. We are calling them x1, y1 and z1 to make it easier to follow. To plot with the scatterplot 3D package, you may want to create an object of your plot using the assignment operator. This will make it easier when trying to manipulate the plot instead of rewriting the code each time. The function we will be using is scatterplot3d. Input the x, y and z variables you created earlier as shown. This will plot your basic 3D scatterplot. Since scatterplot3d builds a 3D plot on a 2D format, it can sometimes be difficult to interpret. Using the argument highlight3d, it will assign a color gradient to the data points, making it easier to see which are closer and which are further away. You can also use the angle argument to determine the perspective you would like to view the graph. This might be useful to further explore the graph. Use the type argument to select the type of point you want on your graph. We are using H as it adds a line from the point to the base of the plot. This is great for gauging depth, but becomes very cluttered with large datasets. There are different types that can be found under the arguments section of plot help. You can also determine the scale of each axis using the scale argument and including x, y, or z. Finally, you can tidy up the graph by adding axis titles using the standard xlab, ylab, and zlab arguments. You can also add a plane that functions much like a line of best fit. Simply build your linear model as shown using the appropriate values. Using the plane 3D function, specifying your plot object, or SP1 as we have named ours, specify your model, and using line type argument, you can decide how the plane will appear on your plot. As with the standard plotting function, you can also use the comparable points 3D function. This allows you to separate your data into groupings much like the group argument of cloud. On our plot, this allows you to easily see the outlier. However, unlike cloud, there is an excessive amount of code involved, but it does allow you to add planes for each grouping.
Plotting the RGL package works similarly to scatterplot 3D. You must build your matrix and determine your x, y, and z variables first. Using the plot3D function of RGL, input your variables the same way as scatterplot 3D. Type equals p is the standard for points. Size changes the size of the points. The labels are self-explanatory. Plotting may open an external RGL window to display the plot, depending on the version of R you're working with. This is nice because it allows you to rotate the plot, as well as zoom in and out. Oh look! An outlier that would have been obscured on a standard 2D plot. This is why this package in particular is useful for when you want to check and understand your data before doing any analysis. In the next plot, we change the type of points to create spheres. With this, we have the radius argument, which is similar to the size argument in the previous plot. If you want to add or change any of the aesthetic parameters, the decorate 3D function is useful. Aspect 3D does the same thing as the aspect argument from the Lattice package, changing the axes ratios. The last package in this tutorial is car. This is the option we prefer, as it utilizes parts of RGL, so you'll need both installed. Its functionality is very similar, but it is much more intuitive than the RGL code. For this package, assigning the plot to an object isn't necessary. We do this to make it easier to follow. As you can see, we first assign the columns from the soils data as named objects in R. The order of the arguments within the function is important. The first term is the x-axis, the second term, pH, is the y, and conductivity is on the z-axis. Like in RGL, the type will change the shape of the points, and size changes the point size. The surface argument adds a plane of best fit. As you can see, this is far easier than scatterplot 3D's approach to adding a plane. However, sometimes a flat plane is not what you require. In this case, the fit equals smooth argument will contour the plane around the points. As you can see, the outlier warps the plane, but it appears that this isn't a good fit for our plot anyway. In many cases, a plane is unsuitable for the data. To better represent the data, you can change the arguments surface and grid to equal false, which removes the plane, and ellipsoid equals true, that adds a data cloud. By default, the axes are different colours. You may wish to change this, as shown. We found this package to be the most intuitive and the best out of the four. This is because it is interactive and easy to add planes and clouds of best fit. It combines the best aspects of the other packages, the simple coding syntax from Lattice, the planes from scatterplot 3D, and the interactivity of RGL.
While 3D plots are not great for analysis, they are a powerful tool for data visualization. They are useful for interpreting relationships and noticing inconsistencies. While 3D plots can be useful for many things, they are often not appropriate, so we advise caution. We hope you have gained a basic understanding of 3D plotting and its benefits from this video. We have provided some links for further reading as well as citations for the software and packages used in the video description. Thank you, and see you all in the next video from the Shiny Stars Stats team.